Hello, in this section we'll cover quantifiers, predicates, and validity. So briefly here, quantifier, we're going to be talking about for all x, or there exists x in an argument or in a sentence, and the predicate p of x, and then we're going to see the validity or the truth value of this propositional well-formed formula. So the validity, that means the truth value of this well-formed formula. So at the beginning, we're gonna need to go over some definitions here, like variables. What is a variable in logic? A variable is a symbol that stands for an individual in a collection or set. For example, the variable x may stand for one of the days of the week. We may say x is Monday or x is Tuesday and so on. And next we're going to talk, so what is a statement or an incomplete statement? So incomplete statement is statements containing a variable may have no truth value and is then called incomplete statement. So if, for example, an incomplete statement will be x has 30 days. Here, x can be any month, and substituting that, we may get a complete statement with the truth value of either true or false, depending on the month. Quantifier, and that's maybe something new. What is a quantifier? So quantifier are phrases that refer to given quantities, such as for some, right? For all, or for every, indicating how many objects have a certain property. So we have two kinds of quantifiers, universal and existential. The universal quantifier represented like upside down A, like this one. And so the symbol is translated as and means for all, given any, for each, for every, and is known as universal quantifier. So later on, we're going to see examples. We're going to take an English sentence and we have to transform it to quantifier predicate, and then we see if this statement is valid or not. And the next quantifier is existential quantifier, which is like backward E, like an E, exist. And the symbol is translated as and means for some there exists, there is, and for all, for at least one. Okay, then the predicate. So where would be the predicate? Predicate, it is the verbal statement that describes the properties of a variable, usually represented by the letter P. The notation Px is used to represent some unspecified property or predicate that x may have. And here's an example. P of x equal x has 31 days. P of May has 31 days. So combining the quantifier and the predicate, we get a complete statement of the form for any x P of x, or there exists x P of x. The collection of objects from which x may be drawn is called the domain of interpretation. So x may be month, or x can be integers, or x can be real number, and so on. So I might say, for example, and you've seen this, for any x, if x greater than or equal to 2, then 2x plus 1 is greater than 5, for example. And this can be translated as for all x, P of x, which means x greater than 2, implies maybe q of x, and q of x represents 2x plus 5, 2x plus 1 greater than 5. For any x, if x greater, so this is a sentence, and then we're going to see if this is valid or not. Or it can be something as this: what is the truth value for all x P of x, where x is all the month, and P of x equal x has less than 32 days. So for sure, undoubtedly, the above statement is true. So this statement is true, since no month has 32 days. So for any x month, less than 32 days. So we know either 30, 31, or sometimes 28, 29 February. So this statement is true. So we continue here and we're going to talk about translation, verbal statement to symbolic form using these quantifiers predicates, okay? When you see every person is nice can be rephrased as for anything if it is a person. So now the domain of interpretation is a person, X is a person, then it is nice. So it sounds weird at the beginning, but we'll get used to it. Every person is nice. You could say it in plain English, for anything, if it is a person, then it is nice. So if P of X is a person, Q of X is nice, the statement can be symbolized as for anything, for all X, P of X implies Q of X. All persons are nice, or each person is nice, will also have the same symbolic statement. All person, each person, it's all represent for all X. There is a nice person can be rewritten. There exists something that is both a person and nice. In symbolic form will be there exists X, P of X, and Q of X. And here we have to pay attention. Variation can be some persons are nice, or there is a nice person. So what would the following form means for the example above? There exists X, P of X implies Q of X. So this is true as long as there is a person in the word, but that is not at all what we were trying to say, right? So hence, almost always, and here we have to pay attention, almost always, when you have there exists, it goes with an and, not with implication. So let's see some examples here. What is the truth value of each of the following well-formed formula in interpretation where the domain consists of the integers? So X is integer. OX means X is odd. LX means X less than 10. And G of X is X greater than 9. So here is what we have. There exists X, OX. Let me write it down. What we have is there is an odd integer. 3, 5, 7, minus 3, and those are all odd integers. So there is some odd integers. That's true. How about B? What does it mean? For all X, L of X implies O of X. It tells me for all integers X, if you have L, right? If X less than 10, then O of X, then X is odd. That's what it tells me. So let me write it in plain English. Well, that's not true. Just because X less than 10 doesn't mean all the X's less than 10 are odd. So it tells me that this is false. There exists X, L of X, and G of X. There exists an integer X such that X less than 10 and X greater than 9. So let's look at it. Stop here and think about it. Maybe you could draw a diagram. We have X less than 10 strictly, and we have X greater than 9. So what are the integer between 9 and 10 integer that makes both of them correct? So the answer is false. So the next one we have for all X, L of X, or G of X. So again, we're going to do the same thing. What does it mean? For all integer X, either X less than 10 or X greater than 9. Is this true or false? So let me write it down. So let's picture it. Here is 9, here is 10. X greater than 9, strictly greater than 9, or X less than 10. So for all X's, integers, either less than 10 or greater than 9. So this is true. because all x's either they're gonna be less than or greater than. So we get everything in this number line. Let's see this next example. What is the truth value of each of the following? Well-formed formula in the interpretation where the domain consists of integers. So x is or y would be integer. So for L, for example, we have for all x, there exists y, x plus y equal x. So you could stop the video and think about it. For any integer x, there is some y. There is one y. That if I do x plus that y that exists, it will give me x. And I would say this is true. And why is it true? Because if I say y is 0, so it's true if y equals 0. Because y equals 0. Because if y equals 0, I could say that there exists, for any x integer, there exists y equals 0, so that x plus 0 equals x. So it's true. So the answer, true. Let's look at the next one. There exists y for any x such that x plus y equal to x. So you could stop the video and think about it. So what we have, if again y is 0, there exists some y. That y make it 0. So that for any x, again, x plus 0 equal x. So again, this is true. That's the answer. The next example I have for all x, there exists y. X plus y equals 0. Again, if I choose y to be negative x, then I would say x minus x is indeed 0. So this is true. And the next one, there exists y for all x's, x plus y equals 0. And I would say this is false. And why is false? Because no one y works for all x's. Let's think of the next one. For all x, for all y, x less than y or y less than x. How about if x equal to y? That wouldn't work. So it's false. And why is it false? Because how about if x equal y? And the next one for all x, x less than 0, implies there exists y where y greater than 0 and x plus y equals 0. And this is true. This is true. Why is that? Because if x equal negative y, then there exists y. X is negative and there is y that is opposite. Because negative y is positive. Because x is already negative, negative y is positive. So if I add them up, you get 0. And the next one we have, there exists x and there exists y, so that x squared equal to y. And this can be, what can be this x and y? If I make x equal 0 and y equal 0, it does work. This one works, and so it's true. And that's when if I make x equal to 1 and y equal to 1. And the last one in this video, the next one we have, for any x, x squared is always greater than 0. And I would say this is false. How about if x equals 0? And then so I would say it's false because 0 squared is not greater than 0, right? So it's false. So the answer is false.